My name is Abdulmajid Yusuf. I'm the head of Geology department. It's a privilege to welcome you all to. I hope you can hear me.
Yes, please, loud and clear.
It's a privilege to welcome you all to this workshop on geochemical fingerprinting in exploration. This topic is centered to modern mineral exploration, providing us with clearer insight into our ore systems and improving the accuracy of our exploration decisions. I believe today's discussion will strengthen our technical capacity and enhance our quality of our geological work. Thank you for joining. Thank you for joining us, and I wish everyone a productive and insight session. Thank you all.
Thank you very much, Mr. Majid. As I earlier on said, today's session is going to be a very educative one. We'll be taking the introduction of the chairperson and guest speaker from Ms. Phillips Boache. She's from KNUST Obuasi campus. KNUST campus, I beg your pardon. Ms. Phillips Boache, please, you may introduce the chairperson and the guest.
Good afternoon, everyone. Please, I'm so sorry, my background is a little bit noisy. Please, can I be heard?
Yes, please.
Hello. Okay. So on behalf of AusIMM, it's my pleasure to introduce the chairperson and the guest speaker for today's workshop on the theme Geochemical Fingerprinting in Exploration, Tracing the Path to Ore Deposits. Our chairperson is Dr. Kofi Adomako Ansah, an economic geologist and immediate past head of the Geological Engineering Department at the University of Mines and Technology, Tarkwa. Our guest speaker is Mr. Kwesi Eduku, a senior exploration geologist at Goldfields, Ghana. However, their full biographies have been published on the AusIMM platforms. Dr. Kofi Adomako Ansah and Mr. Kwesi Eduku, please, you are warmly welcome, and we look forward to an insightful section. Thank you.
Thank you very much.
Thank you very much.
I believe we've all gone through the profiles of these professionals we have on our midst here today. And if you've done so, all you can say is wow, from the experience they've gathered throughout their years. We'll be taking the chairperson remarks from our very own Dr. Kofi Adomako Ansah. He's an economic geologist and a senior lecturer at the University of Mines and Technology, Tarkwa campus. Doc, please, we are ready for you.
Right. Thank you very much. Can you hear me?
Yes, please.
Okay. Right. To all your wonderful members of the association, I salute. And to my dear colleague, the guest speaker, I also welcome you to this platform that we are all going to be sharing together. Yes, I want to say thank you very much for the opportunity to, and then of course, all those who are joining us far and near, we salute you all. I want to thank you very much for inviting me to join in this program to discuss about using geochemistry in exploration, the application of geochemistry for exploration. I am deeply honored for being considered to chair this occasion. And I believe that as we have come together to share our ideas and thoughts on the application of this extraordinary principle or tool, you leave this program or this workshop well indulged in the processes, the applications and success of exploration geochemistry. I hope everyone will be available and we will have a wonderful time together. Thank you very much for the opportunity.
Thank you very much, Doc. We are truly honored to have you chair this workshop. So the topic for today is geochemical fingerprinting in exploration, tracing path to ore deposits. I'm sure most of us here are wondering what this topic entails. Well, we have a very experienced individual in this field that will be shedding more light on the topic. Ladies and gentlemen, kindly help me to welcome our speaker, Mr. Kwesi Eduku. He's a senior exploration geologist at Goldfields, Ghana. Please, sir, if you can hear us, you may take over.
Okay, thank you very much. I appreciate all of you making time to join this meeting. I'll be sharing my screen so that you see a very short presentation that I made for this meeting, just to try and explain what entails geochemistry being used in exploration. So if you permit me, I'd like to share my screen right now.
Sure.
Okay, so I'm sure everybody can see my screen, right?
Yes, please. I believe we can all see.
Yes, I can see.
Okay, so as today's topic talks about geochemical fingerprinting in exploration, so tracing the path to ore deposits. So as geologists, one thing that I'd just like to say that as a when you are practicing geology as your profession, you are basically a forensic scientist of the earth. You are just following clues that have been left behind by ancient ore forming fluids, and then clues that's also been left behind by various many processes that has geologically altered the earth. So as we all know, the deposit is the destination. That's how I like to call it. But our journey is along the path that has been paved with chemical evidence. As geologists, it is our job to read this evidence. So let's just start my presentation. So what is geochemical fingerprinting? What we know concerning fingerprinting in exploration, we are exploring for something. Most of the time, we are looking for a deposit, an ore deposit, which is not just a pocket of metal that appears out of nowhere. Nowhere. It's actually coming from somewhere. It has a source, and there might be some geological processes that took place that put that ore deposit there. And some of these, most all deposits carry a unique chemical signature, depending on the kind of mineral system that puts it there. Okay, so identifying and tracking these distinct signatures left by these fluids that form these ore bodies is what I'll just term geochemical fingerprinting. It is also crucial that the ore body is the heart of the system, but as fluids spread out, they affect the much larger volume of the rock. And this altered rock that surrounds these ores we would generally term them as halos. So as every human being has a fingerprint, similarly, like example, like a porphyry copper system, it has a chemical personality, stuff that you look at when you are tracing these ore bodies. So what we do know is that most of these ore bodies are brought about by hydrothermal fluids. I'm sure everybody who knows this, like as a geologist. So when you are, the challenge in, I'll term this short one, exploration the exploration challenge, finding a needle in a haystack. So basically, let us look at a copper deposit, which is probably the ore deposit is probably 1 kilometer in diameter and is buried under 100 meters of waste rock. Now, what you see, the image that you see on your right side is just that's the ore body, and that's the halo around it. So, like I said, the hydrothermal fluid that deposited the ore body also creates a halo around these ore bodies. And most of the time, before you arrive at drilling, there are so many processes that you must follow. And I'm just going to focus on geochemistry of that. There are so many. You can follow geophysics, you can do, you can employ cheaper methods of drilling like auger, reverse circulation, air core, and the rest. So, but we'll just focus on geochemistry. So, can everybody hear me?
Yes, please.
Yes, please.
Okay. So let us contrast this 1 kilometer deposit that I spoke about earlier, which is surrounded by a 10-kilometer wide geochemical halo. We just increased our target size by what? 100 times. Instead of looking for that needle in that haystack, we might actually focus on that hay. And that halo of ours becomes that halo that we use as a signature to pinpoint and target the ore. Now, to do this, there are several components of fingerprinting. We have pathfinder elements, isotopes, which I'll talk about in the next slide. But moreover, what you see on the right side is the periodic table, which shows trace elements and pathfinder elements that we usually use in geochemistry. So as these targets form, they create what we call the halos that are created are also composed of these trace elements. And depending on the type of deposition or the kind of deposit that you have, will determine the kind of trace element or path elements that you are supposed to follow. So for porphyry copper deposits, which are usually copper rich, you might look at copper, molybdenum, silver, arsenic, or antimony as a pathfinder elements in tracing deposits like this. And also volcanic hosted massive sulfide deposits, which are usually formed under sea. Okay, also bear their own characteristics of trace elements and pathfinder elements, as you can see in the slide. And also like the last but not the least, orogenic gold deposits, which you can probably find in our 6 to 7 gold belts in Ghana here. They all bear their own characteristics. Needless not to say that you use the same formula in finding or pinpointing the deposits in an ore body in these deposits that I've spoken about. Everyone is characteristics to themselves. So you cannot say in the Takoyan, which is a paleoplacer element, you probably use the same method as you would use in the Birimian. Okay, so one example that I would like to give is that these pathfinder elements, they act like canaries. Let me use back in the days, the miners used to use canaries. I don't know if anybody knows the story in underground mines. So when you have how do you call it, poisonous gases in mines like hydrogen sulfide, when they are underground, they usually carry canaries in cages when they go underground, because these canaries have like high metabolism rates. They do sense some of these poisonous gases earlier than human beings. It's like very fidgety and active. when they do sense these gases, they tend to become weak and quiet, and then that gives these miners the idea that, oh, this is what is happening. So these canaries, like I'm just saying, you can attribute them to these pathfinder elements, and then the poisonous gases that are coming out is like the ore body. I'm sure you can get my the relationship that I'm trying to promote here. So one thing that I also want you to understand is that elements such as arsenic, antimony, and mercury, they often form volatile compounds. And the reason why they are able to move far away from these ore bodies is that they are able to attach themselves to water or turn themselves into aqueous and gaseous states easily. They're able to attach to water and hydrogen and oxygen and move themselves around in the ground, around cracks, structures, faults, and whatnot, and also precipitate and then stay where they usually find them when you are picking samples. So I would like to talk about component ratios in element ratios and zoning in fingerprinting. So like I said, anyone who understands the Bowen's reaction series, okay, this is just heat and pressure. So ratios act as what? Thermometers. Element ratios tell us about physical and chemical conditions. A high copper molybdenum ratio in a porphyry system points out that you are getting closer to a copper deposit. So like the image that you see on your right, imagine you have a hot metal-rich fluid that is coming out of the ground, okay, in a porphyry copper system. Now you have the much more unstable elements precipitating out, falling off first. I mean, the main deposit has been put down in the ground, which is your copper. Now you have the trace elements in the fluids and pathfinder elements in the fluid moving away from your ore, which can be tens and thousands of kilometers. But let's just bring it down to something that's close. So your less mobile elements like copper and molybdenum, they will fall off, and the fluid will continue to move outward of your core, which is the main deposit. It will move outward, and then you have lead and zinc, which can no longer stay in solution. They will also fall off, and then they will form a shell around your copper and molybdenum. Then as you progress further, as the liquid begins to cool more and more and more, you have manganese, silver, antimony, and the rest also depositing in the outer shell. So let's just say you go on a field. Let's just imagine this as a flat field, and you pick a sample. You run geochemical analysis on it, and you realize that you pick so many samples on the field. One sample gives you silver, another sample gives you lead, another one is giving you zinc, and the rest. It should tell you based on the position of these samples on the ground, should actually point you in the direction in which you should look. I'm not saying that what it will give you would point you exactly to that deposit, but I mean it's an indicator, and it's something that you should look at. As we progress with the slide, you understand some of the limitations that you can run into when you're using this method in exploration. So I also like to talk about isotopes. Everybody knows that isotopes are atoms of the same element, which have the same number of protons and then different number of neutrons, and also have different atomic masses. This is just a small understanding I have on isotopes. So in fingerprinting, okay, you have in fingerprinting, you have pathfinders telling you what So like your copper molybdenum tells you that, oh, you're looking at like a copper deposit. An isotope will tell you where from. Okay, it can give you the age, how old it's been there, and that kind of thing. So, as I was saying, if you are looking at isotopic signatures, you should be considering some elements like chlorite, some minerals like chlorite and then pyrite. So some of these minerals attach themselves or have some elements logged in their crystal structure. So you can have an example like the composition of chlorides changing systematically with temperature. So if you analyze the chloride sample from a drill hole, you can estimate formation temperature. So let's just say you have more, whatever ratio or isotopic signatures that you are looking at. You have a drill hole which goes downhole. The more you have the concentration of this chloride sample, the more it's also telling you that, oh, you are probably moving towards the source. Okay. So minerals like also pyrites, they are not pure. They may also contain tiny traces of some of these elements, which may be locked in their crystal structure. The amount of these trace elements is controlled by conditions such as temperature, pressure, and then fluid chemistry when the mineral was formed. So isotopes generally, they act like a DNA test. Okay. So if you have the definition of whatever isotopes that you are looking at, that should also point you in a direction. So I would like to talk about the exploration workflow that you can usually geochemists follow when they are conducting the exploration programs. Okay, so the exploration workflow, I like to look at it as a funnel. You start on the original scale, and then if you are successful, I'm stressing on the word successful, you end up with a discovery. Okay, most of the times people think that once you've been allocated a budget to conduct exploration, you should always bring a deposit or you should also always make a discovery. It's not all the time that you make a discovery, but from the process from start to finish helps you learn a lot about the area that you're conducting your exploration on. So usually, if you were to start your exploration and then you want to consider using geochemistry in helping you target your ore body, you should know that when you start with your desktop studies, those who have learned geology of Ghana, I mean our students who have learned geology of Ghana know that you can't just get up and start exploration in just anywhere on in Ghana here. I mean, you can go and get a acquire concession somewhere in Accra and say that, okay, I want to explore for gold. You and I both know that that's not possible. So usually you start on a regional scale based on your area of interest. And then you conduct soil sampling. So soil sampling, you pick soil samples from the ground, probably a depth of a half a meter or more. So we're on a regional scale, you have to run a very sizable grid, because if you have a scale of, let's say, 100 square kilometers, you can't start picking your samples in a grid of 100 by 100 or 50 by 50. You pick a lot of samples and you spend a lot of money doing that. So you start on a reasonable scale, let's just say 400 by 100. So every 100 meters along, you pick 100 meters. Every 400 meters along, you can pick 100 meters across. So with that, you can zone out and go to the district level and do infill sampling. So basically, you just don't zone out with just how do you call it, your geochemical interpretation. I mean, you're looking for something, and if it is good, your progress should be backed by your assay that you're getting from the lab and how good it is. You can't just use geochemistry as just a tool to zone out and start doing infill sampling. So whatever interpretation that you do, based on what I spoke earlier, next slides, we will see some of the methods and machines and techniques that you can use, and then in helping you do this. So as I was saying, when you are done zoning out and doing your infill sampling, you can just progress, run a detail grid, close the gap down, or you can run trenching, field mapping. You can also employ other exploration methods, other exploration tools like geophysics, drill, less expensive drilling like auger, air core, or you can do trenching. And then most importantly, you should also do field mapping, go out and collect your structures, and then that should also inform you on your trend based on your strike and dip. So when you do make a discovery on a deposit, then you can do your target definition, do your drilling, resource modeling, and then resource estimation. So let me just use a hypothetical case study for a porphyry copper deposit. Like I said earlier, if you were to pick your soil samples on a regional level, you running assay test, you should back you trying to follow the geochemical path, you should also back it up with the assay results that are coming for your assay results that are coming for copper concentration in your samples. So for, as you see on the image on your right, you have streams running through your concession. You can also pick stream sediment samples, and you can also pick soil samples. So stream sediment samples might not necessarily represent the exact representation of what's in the ground, because it's on the riverbed and it must have been carried out. And it's in flowing water, so definitely has been carried up from carried and settled somewhere from somewhere. So like I said, with your soil samples, you can run geochemical analysis, and your copper and molybdenum concentrations during your geochemical soil analysis should also point you in a direction. But you should always make sure that it correlates with your assay results before you make an informed decision. So when you move from a regional reconnaissance sampling to a district scales targeting, your sampling should reveal zone or zone patterns of manganese and then arsenic as your halos, like I spoke about earlier, and then your inner lead and zinc zones. That should also help you out in your targeting. So you can go ahead with, like I said, reverse circulation, which is talking about the rock chips. When you run your geochemical soil sampling on those two, that should also tell you your interpretation. Okay, so one thing that I also like you to know, that when you're on the prospect scale, you find rocks with high copper and high copper molybdenum ratios, and these ratios should be showing you the direction that you should be going to. So should you proceed to drilling, your drilling might not hit the target exactly, but your interpretation on your drill core and then your analysis on the drill core should actually give you an indication of how close you should be, and that should inform the progress of your drilling, where you are going to drill next, the direction in which you are going to drill, and most of the times the depth that you are going to employ when you are doing these drilling. So I like to talk about analytical techniques, modern laboratory methods that are used in geochemical interpretation. So, like I said earlier, you can think of streams sediment samples as natural sample collectors, draining and mixing of rocks in a huge area. So if you have a river or a stream running in the valley of two hills, that should actually give you an indication of looking left and right on what the sample in the riverbed is telling you. Also, soil sampling too is similar to this. Now, I'd like to talk about ICP-MS, inductive coupled polarization mass spectrometry. So this usually most labs use in collecting geochemical data from your samples. You can detect most elements on the periodic table at concentrations as low as parts per trillion. So let me bring it down for you, the students to understand. So when you're saying like parts per trillion, that's like finding a single person in a city out of like a million or billion people. That's how accurate this machine is. So when you talk about mass spectrometry, it's just measuring the mass of these elements and then recording them and then giving them to you. So you can also use a portable X-ray fluorescence machine. You can see the gun over there. Most of them look like this. So that is a very cheap and inexpensive way of collecting geochemical soil sample data. You can just collect your data on the field. So I usually call this a geologist tricorder. Tricorder means that it's what does three things at a go. You can also look at laser ablation ICP-MS. This is just focusing a laser on. This is a non-destructive process. So it focuses a laser on your sample of interest and vaporizes part of it so that the mass spectrometer can pick up and measure the elements in the gas that was produced from the laser. There are other methods that you can also follow, like the shortwave infrared spectrometry and then isotope ratio. These are all mass spectrometry machines, but different ways of acquiring these elements and trace elements. So I would like to talk about some of the limitations that comes with using this method in exploration. So I'd like you to understand that geochemistry is an interpretive method. Okay, based on your interpretation, that will inform you what to look for, where to look at. And one thing that you should understand is you should really understand geochemistry before you decide to go by this method. But most of the time, some of these interpretations are carried out by experts who have been in the field of geochemistry for a long time. Okay, so some of the key benefits is if you have a very large area, it can help you pinpoint your deposit. It's very cost effective as compared to other methods like drilling, uh, geophysics, and whatnot. It also helps you find blind deposits. Let's just say you have a very thick overburden over a deposit. Definitely, you might have some mixing. I'll talk about that in the disadvantages. So you have thick overburden. Collecting your soil samples can also help. I mean, sometimes you can have leaching and then erosion from certain parts of some certain areas that can actually deposit soil samples at different places that can help you pinpoint you in the direction that you're looking at. So let's just move on to the disadvantages. So I would like to talk about the fact that if you have different mineralizing systems that have happened in the same area, you can have mixing of signatures that can actually make it hard for you to pinpoint you in that direction that you're looking at. Also, weathering, like I spoke earlier, weathering and transportation of leach materials, eroded materials, and then loose soil samples these can be transported very large distances. I mean, when you have agents like water in seasons when they are huge flooding, you can have some of these issues. which can obscure or affect your interpretation. And like I said, it requires expert interpretation. So it's just not everybody who can just learn a little geochemistry and then come out with that, okay, fine, this the little that I've learned, so let me just go ahead and then use this or employ this as a tool. Sometimes you need someone who has been experienced in this field and to help you out with some of these interpretations. And it also requires the understanding the use of some of these software that we use in our interpretation, like IUGAS, for example, is a very great and powerful tool in geochemistry. And if you don't understand or have a grasp of how to use the software, you might also limit you in some of these things. So some of these future technologies and emerging trends that can be used or employed with geochemistry. So we are in the age of AI, and our artificial intelligence just keeps on advancing. And nowadays they can do a lot of things that some 5-10 years ago we never thought was possible. I know a day will come, probably not in our lifetime, where you can have a satellite out there just scan the earth and just run some of these analysis and interpretation for you without putting it that much work on the field. Although some of these technologies are now emerging, I know a time will come, some of these things will be possible. Some of these things that we see in science fiction. Maybe you might even have a portable ICP-MS machine that you can take on the field. You can have an XRF machine that's as small as a phone and that kind of thing. But I know as time goes on, if some of these things can be integrated in machine learning and then data platforms, we can have artificial intelligence programs that can be designed to run some of these analysis and analytics for us, and also generate models and reports that can also help us in our interpretation. Needless to say, I also want you to understand that it is not every geological setting or every location or area that you can employ geochemistry as a tool in your discovery. Sometimes it may work, sometimes it might not work. So one thing I also want to conclude, in my conclusion, I want you to understand that, like let me use how do you call it, football match as an example. So no, let me scratch that. Let me use like a Formula One race as an example. This early morning, anyone who follows Formula One should know that in the championship we have Lando Norris and Verstappen battling for first position. And the McLaren boys were disqualified today after their race. So that's just blown the championship up wide open. Someone may call it luck, someone may call it cheating, someone may call it the ball that has fallen in Verstappen's court. But one thing that I also want you to know, that as you might look at luck and science, they go hand in hand together. And sometimes you might consider an analytical method as not possible in a particular terrain that you are looking at. And sometimes you might abandon it and then leave the target altogether. Someone might come and then use whatever that you decided was not possible in determining something and finding something. It's happened so many times. Okay. And I also want you to know that geochemistry usually it does provide a systematic path for regional anomalies discovery. Okay, so multi-element approach with ratio patterns is crucial. Once you understand some of these things, it makes it easier running a model and then running the software for your interpretation. It does help, and it can also help you in pinpointing your targets. So one thing, let's all know that, and let's all try and immerse ourselves in some of these methods. I have not seen that much geochemistry being used in this part of our country. I mean, in Ghana, but it does work elsewhere, like in Australia. The geologists over there do use it a lot. So let's try and integrate it into our data sets, and then I also ask our academia to also get themselves involved in geochemistry, and then let's run some research. So thank you very much for your time. And this an image that's showing some of our geologists using the XRF gun to pick data from core samples and then soil samples in the field, the ICP-MS machines, and then also an AI generated image of a drill rig trying to drill and collect core samples based on geochemical signatures. So thank you very much for your time.
Thank you very much, Mr. Kwesi Eduku. This has been such a wonderful presentation. Indeed, geochemical fingerprinting transforms luck to science. I've learned a lot from this presentation, from how element ratio and zoning in fingerprinting is done, to the skills flow of how exploration is also done, from regional to district to prospect, then to local. That's in order of increasing general to specific. And I also learned about some modern analytical methods. I hope most of us, if not all of us, have learned a lot, and I've gathered some questions down. We'll soon be moving to the question and answer session. But before that, we are honored to have our founder in our presence. Kindly help me to welcome Engineer Henry to give his remarks. Engineer Henry, over to you.
Thank you very much. Can you hear me?
Yes, please.
Okay, first I want to thank the chairman and the speaker, and this demonstrates industry-academia collaboration in these workshops. But first, let me acknowledge that since we introduced these course-specific workshops, it has exceeded expectations. In all the workshops, we have seen over 100 participants, especially people from external out of the AusIMM participating. So today I want to acknowledge a certificate of appreciation to the head of the geology group, Mr. Abu Majid Yusuf, for such strong organizational skills, pulling it all together with his team. So thank you very much for that. I also want to acknowledge the leadership of the entire AusIMM team and yourselves for bringing this together. This will be the last for this year. The one left is UMaT, and they are working on this. A date will come very soon. But what this has done is bring in, expose the AusIMM externally. And as I speak with you now, I've got about 12 local and international speakers wanting to share knowledge with you. Next month, a UK-based medical officer wants to do a webinar on mining communities and health, how the extractive industry shapes local communities. That will be, the flyer will come out soon. And there are other speakers from the United States, Ghana, and so on. So thank you for this. But I want to situate my remarks on the importance of geology in the mining cycle, because until recently, we have underestimated the importance of geology across countries, especially in the Western world. And it all came to the fore when this discussion on net zero emissions, transition energy, and so on came to play. And all of a sudden, especially in Australia, we realized that we are not producing as many geologists as we should. Why is that? Because we need a lot of critical minerals, copper, and so on. And so a lot of attention went onto the universities. And what happens in Australia, Canada, and the United States is parents are tired of geology, because as soon as commodity prices come down, sometimes they are the first to cut. The companies cut exploration. And so it becomes a challenge. Just to give you an example, 2022, global exploration spend was about $13 billion. this came down to drop to 15%, dropped by 15% in 2023, and another 7% drop in 2024. And so whenever there is pressure on commodity prices, we see exploration spend coming down and so on. But the emergence of critical minerals is playing a key role in geology, and therefore governments have started introducing grants, scholarships for students to undertake geology. In fact, it became so bad that a professor told me that in one particular year, only 5 people signed up for geology in year one. That's how bad it became. And so if you look at the Australian Skilled Migration Program, you see that a lot of emphasis is going into geologists, attracting geologists, especially from Zimbabwe, Zambia, Ghana, South Africa, and so on. But not only that, governments are giving grants to geologists who can demonstrate technical competence and entrepreneurial skills. In Australia, the states are giving grants. If you're a geologist and you come together as a group and you demonstrate that you can do exploration, you get free grants to go and explore. And that is the reason why Australia has become one of the largest producers of copper, because of the strong resource base. But it's not only governments, companies. BHP is a typical example, which is giving grants to junior exploration companies to explore. And their intent is, once you find a deposit, they will do a joint venture with you, because building the mine is the most expensive aspect, hundreds of millions of dollars, and you will not have the cash. So they will do a joint venture with you and build a mine, and all of a sudden you are millionaires. And they have premised this model on Ekati diamonds. So Ekati diamonds is in Canada. 2 geologists around 1991 discovered the first diamond-bearing kimberlites in Canada. And then later on, a company joined them, was sold to BHP. It became one of the largest diamond mines in the world. And in fact, as of October 2024, they have produced 100 million carats of diamond. So based on the success of that, BHP has decided to engage junior players, where they'll give you the cash and mentorship to find ore bodies. But why is that? It's because of geological risks. Let me come back to Ghana. The reason why UMaT Alpha North has taken so long is social license, community agitations. So that becomes a geological risk. If you look at the lithium projects, when they finished all the feasibility studies, it was all looking good. And then there are fiscal terms, which a lot of Ghanaians didn't like, that they were cheating Ghana. And all of a sudden, lithium prices have collapsed by over 80%, and their project has become uneconomical. That's a geological risk. And therefore, they have to go back to government to water down the fiscal terms that were broadly rejected by Ghanaians. So that's an example of these geological risks. I've been involved in projects in Canada where we spent about $40 million, and iron ore prices collapsed. The project stalled, and for 5 years, we couldn't get it running and so on. But let me now situate the discussion on Ghana, because I'm glad that the speaker used copper as an example. I was at an international conference as a keynote speaker with one of your ministers. And then in his speech, he said there's a lot of base metals in Ghana, nickel, copper, and so on. So all those who were asleep at the conference woke up. Oh, copper in Ghana, interest. As I was engaging him, he packed up his stuff and left. So he didn't take questions. Because I'm from Ghana, I was in the hot seat. Everybody is asking me, what is this copper and so on. I have no clue. And so I engaged a mentee at the Minerals Commission to look for some information on this copper. As of now, she hasn't come up with anything. But I'm saying this because a lot of your research these days have to go into enhancing the geological potential of Ghana, especially your final year projects. Around 1971, a lady by name Alexandra Amwako-Mensah published a thesis on geochemical aspects of spodumene pegmatites of the Salt Pond area. And that thesis in 1971 guided the lithium find in the Ewoya area. So this was way back in 1971. And you never know what your thesis or what your project work will do in 5 to 10 years. And so I encourage students, professionals to tailor some of their research into geological find. Go to the Geological Survey or Minerals Commission. Somebody should take it as a project or a team of you and see whether you can find any information, whether it's geophysics, geochemistry, whatever, on potential copper projects, deposits in Ghana. And in 5, 10 years, you might be a millionaire and so on. Now, I also say this because of late, there's a lot of potential coming out of West Africa, especially Ivory Coast. I'm the chairman of the board of a company called Instroma Resources. And the goal of the company is to own mines. So how do you own mines? You own mines through acquisitions or expansions or exploration. Now, if you look at exploration, Barrick has been very successful in growth through exploration. Why? Because the CEO has a PhD in geology and is one of the best in the world in terms of finding deposits across the world. So he had a philosophy that I'm not going to acquire mines, I'll do exploration. But it all backfired on him, and he had to resign recently when their operation in Mali was taken over by the military regime. It's still going through negotiations, but it's been down for almost a year now. And that brought in political risks and so on. And so if you look at companies like UMaT, they go 2 ways: cautious exploration and aggressive acquisitions. Recently, they acquired Newcrest for $17 billion to expand their portfolio. And all of a sudden, a project like I have for UMaT is no more in their criteria of good assets that can produce more than 500,000 ounces. That's why they sold it to Zenjin. The Chinese company Zenjin has also an aggressive policy of acquisitions, but they also acquire to explore and so on. But these acquisitions also come with their challenges. Because if you get the geology wrong, you can overpay. And I've seen very, very bad valuations that have happened in my lifetime. I was managing a $2 billion fund for a government. And the purpose of the fund was to invest in mining projects so that they can bring the minerals back to the country for industrialization. So one of the multinationals approached me and they said, they have this fantastic iron ore project in Brazil. They estimated that they had about over 1 billion tons of iron ore. So by their valuation, that's taking 25% of the project required that we paid $2 billion. Now, if you can imagine that Ghana went to the IMF for $3 billion, we are buying a 25% of a mining project for $2 billion. But as usual, I will spend about $1 million to get expert opinion before I invest in $2 billion, because in the scheme of things, $1 million becomes nothing. Get it right. So we conducted a technical.
Please kindly mute yourselves.
So we conducted technical, commercial, legal due diligence. We came up with a valuation of $1.2 billion, and we could not close the gap. But why was our valuation quite different from the company? Because our experts were telling us that they've got the geological resource wrong. It's not over 1 billion as they are saying, it's around 200 million and so on. A few months along the lines, the group CEO and a number of executives were fired when they realized that they have actually overestimated the valuation and so on. Another example is we were in Mozambique trying to close a deal. We flew to Sydney. The following morning, we are going to close the deal. The negotiations have all finalized. We're just going to have a signing ceremony. 8 p.m., I got a call that the meeting has been canceled. 10 p.m., somebody from Macquarie Bank told me Rio Tinto is taking over that company. And imagine a group of geologists who have spent $100 million in Mozambique. All of a sudden, the project was bought for $2 billion by Rio Tinto. They became millionaires, just like that. And so the chairman of my board called me and said, go and strike a deal with Rio Tinto. Because if Rio Tinto thinks this project is $2 billion, then it's $2 billion. And I remember telling him, you will have no sleep if you pay $2 billion for this project. A year after that, Rio Tinto sold that $2 billion project for $20 million. They got it all wrong. From geological resource to logistics to infrastructure, everything was wrong. and that led to a lot of dismissals. So both geological risk and exploration, acquisition too, if you can get it all wrong, and so on. And so when I became the board chair of Instruma, they said they want to do acquisitions and also do cautious exploration. We tried the Bogosu Christia acquisition. We couldn't get into proper terms with Blue Gold at that time. Whatever they were expecting was too high for us, so we backed off. Now, 2 weeks ago, an Australian company contacted the group, and they said, we are explorers. We've been very successful in Australia. We've raised a lot of cash from the Australian Stock Exchange. We want to do a joint venture with you into projects in West Africa. And I said, let's prioritize the countries. And the shocking news was they put Ghana as a low priority area. Their focus is Ivory Coast and Senegal. And if you want to know the reason, it's very simple. They don't want to spend all this money for illegal miners to take over the concession. That has become a big risk for investors. And that's why there's a lot of exploration capital flight across to Ivory Coast and so on. And so I went through a process to hire some of your graduate trainees who have been kicked out after their time, went through a process to interview some of them. And the shocking thing was, when we were doing the interviews, I asked specific questions. Do you have a passport? They said yes. Do you have a driver's license? They said yes. We shortlisted 4 people, gave them letters of offer. Now we are ready to ship you to Ivory Coast. Oh, our passport is still pending. It's still in the system. We haven't received it. Now, number one, that is deception. And so I want to spend a little bit of time talking about attitude and deception. You don't go to interviews to deceive people. First, if you're a professional, especially if you're a geologist, the first thing you need to do before you graduate is to have your driver's license. And some of you don't take it very seriously because geology is such an expanded area. Sometimes you have a very big, wider area to explore. And in the Western world especially, we are not used to hiring drivers to drive professionals around. The CEO drives himself around. So you are a geologist, you have to drive yourself around. Passport, very important. You never know what will come as a geologist or mining engineer or whatever and so on. So you just have to be ready when these opportunities come and so on. The only one guy who was ready is currently in Ivory Coast undertaking French classes. If you have the opportunity to do French, also use it. But I want to take this opportunity because the speaker talked about AI. And AI is becoming very, very critical in exploration, especially in Australia and Canada. Now, a group of geologists came together. They formed a company called Goldspot. And they've been able to use machine learning algorithm to identify 86% of the deposits in an area just by assessing 4% of the total surface area. What it means is they use this AI algorithm to identify targets and then zoned into those targets, which was about 4% of the total entire area, and was able to identify 86% of the gold in that particular concession. Recently, they also highlighted 19 high to moderate prospectivity lithium tantalum projects in Canada. And all of a sudden, big companies are outsourcing their geology to these guys. They are not going to spend too much money drilling, so they want geologists with experience, like your speaker, who has a lot of experience, can do interpretations and so on. And they want geologists who can do resource modeling. And that's why I keep telling a lot of you that if you want to make yourself marketable, one of the key areas is resource modeling. Have a job competency certificate to be able to sign off on resources and so on. Last week, we had 6 geologists from Ghana entering Australia because they have expertise in the area and so on. I'm not saying leave Ghana, but if you want to make yourself marketable, those are the areas. Now, let me spend my concluding remarks on attitude in the industry. And I'm going to give you 2 examples of good attitude and 2 examples of bad attitude so that you can relate practically. I'll start with the good ones first. While I was going around the Ghanaian mines some few years ago, I met a lot of professionals in the field. Sometime last year, one of them sent me a message that his contract at UMaT, geology contracts, had expired. It was not renewed. He's been home for about 2 years. So the question was, what have you been doing in 2 years? I used my small savings to set up a business. And then I said, how do you go about your accounts and ensuring governance and so on? While I was home, I did project management as part of my master's in business administration. And I've done other courses as well. So I'm able to manage it. That is a positive attitude. He didn't tell me that he's been staying home. So straight away, a colleague of mine was looking for a project manager in the DRC. And I linked her to the colleague. They had an interview, and she's a project manager in the DRC. You see, she came in with the right attitude. Now, when she called me last, she said, "You've thrown me in the deep end," because I was expecting to do some geology, but this is purely project management. And the bad news for her is she's not meeting her targets because the people are so lazy. They don't come to work, they are late, and so on. So I gave her advice. If you take the Ghana culture of give it to God, Famanyami, and all that, you are going to fail. Start firing people, and they'll wake up. So she told me she fired 3 people, and now they've given her a nickname, Iron Lady. She doesn't like it, but at least they are performing. A second example of good attitude is somebody, maybe he's on the platform, so I won't mention his name. He's been kicked out after national service, but it's always positive. I've been kicked out, but I'm working in small-scale mines. That is good. And then later on, he called and he said, "I've set up a company with my colleague geologists. We want to own our own small-scale mines, but we need guidance." I had a Zoom call with them and then realized that they were lacking on the strategy side. But I picked him up and I told my colleagues, this is the guy that we need to groom for Ghana. He's got the positive attitude, he's got the entrepreneurial skills and so on, but he didn't have the practical experience. My colleagues, we made some few calls, and now he's gone back to the mines working as a geologist. In fact, he's now gone beyond graduate training and has a contract. Recently, when I was in Ghana, I was in his area at a resort, enjoying myself a little bit, and I said, "Come over for dinner with one of our AusIMM executives." What he didn't know was I had invited the general manager as well. The general manager also didn't know that these guys were present, so they all showed up. And for 2 hours, they had interaction with the general manager. And they were telling me we don't even get 15 minutes on site to see him one-on-one. Very relaxed, he telling them about their long-term plans and so on. So these are examples of positive attitude. Now, negative. I come from the Adansi area, and I get a lot of my community people approaching me that, in fact, one lady said, what's the word? Why is AGA employing so many foreigners when community members are sitting there unemployed? And I told her to define the word foreign. Is somebody from Accra a foreigner? She said, yes. Anybody who is not from Obuasi is a foreigner. Then I asked her the question, do you really come from Obuasi? She said, yes. And I said, I can guarantee you, go and ask your parents that nobody is from Obuasi. Obuasi belongs to my great-great-grandfather, the Akukare chief, and then the new Eduku chief. They owned Obuasi land. So anybody living in Obuasi is not from there. You are just living there. So stop this attitude that you are from Obuasi. That was point number 1. Number 2, assuming that you are from Obuasi, did you participate in their tests and interviews? She said, yes. This test is transparent. What was your score? 45%. So I asked her the question, are you expecting that Obuasi mine will take your 45% over somebody from Accra who got 90%? Is that fair? Number 2, this gold in Obuasi doesn't belong to Adansis. It belongs to the people of Ghana. So I'm saying this because a lot of you who are from communities have this sense of entitlement, that because you are from the area, it's a must that you should be given jobs and so on, even if you don't qualify. And so that comes with negative attitude and so on. The last example is a classic case of a mining engineer who has been home for 2 years, got opportunity to do assessment tests and interviews, got in, finished the medicals, given appointment letter, start on this date. She never showed up. In fact, I thought she was there until I got to the mine. And then I was at the managing director's residence, organized some barbecue. A lot of the graduates came over. And I said, where is she? They said, oh, she didn't show up. And when nobody knows why she didn't show up. So I called her, why didn't you show up in Obuasi? Oh, because I had a contract with another mine, and the contract is much better than graduate training because it's stressful. After graduate training, I don't know my future. I said, that's fantastic. But all you have to do is to tell Obuasi that I'm not coming. Tell the company that I'm not coming. And you don't have to cite the reasons. All you have to say is for personal reasons, I'm not joining and so on. Now, I wasn't surprised that after the contract, it wasn't renewed because you cannot go into the industry with these type of attitudes. So I'm encouraging you, while the process is so frustrating, We have undersupply, high demand in the Western world, you have oversupply. But the visa requirements ensure that we don't just employ people without experience. They want experienced people who can also train the locals and so on. Take your time, build up your expertise, have the right attitude, and you'll make things better for yourselves. Thank you very much. And for those who are not AusIMM members, we encourage you to participate in all our webinars and workshops. We appreciate your being here. Thank you very much.
Thank you very much, Engineer Henry, for highlighting the dynamics of geology and how to navigate the workplace with us. So we are at the question and answer session, and we have a pool of questions on the comment section already. So I'll be reading out the questions to our speakers to tackle them for us. This is from Mame. She's asking, what type of geophysical method is used to determine the pathfinder or the resource beneath the earth? I believe this is to Mr. Kwesi Eduku.
Oh, okay. So when you look at geophysics is not looking at pathfinder or trace elements. Geophysics is looking at the properties of the ground. Okay, it's looking at how current flows through the ground, how the ground resists the travel of currents through it. It's looking at how seismic waves passes through them. Some of these are all physical properties of the ground, and that's what geophysics focuses on. Geochemical is looking at the chemistry of the earth or the chemistry of the ground. So that's the difference. I hope my question, the question was answered.
I believe so. So next question from Desmond Apia-Quenin. He's saying, thank you, Mr. Kwesi, for a wonderful presentation and the insight shared. Please, I would like to ask, how do you differentiate primary or related geochemical anomalies from secondary? That's weathering-induced. Weathering-induced signatures in tropical environments like Ghana. Please, did you get a question?
Yes, I did get a question. Can you please just go over it again, please?
Please, I would like to ask, how do you differentiate primary or related geochemical anomalies from secondary signatures in tropical environments like Ghana?
Okay, so looking at primary or what initiatives?
Primary or related geochemical anomalies from the secondary.
Okay. So like I said earlier concerning how do you call it? The ore being deposited and then the halo being created around the ore. So when I spoke about ratios, now you have your outer shell and then you have what's probably in the middle and then what you find when you are getting closer to how do you call it? The deposit itself. So when you go out and you pick your samples and you run your analysis, you should know there are some elements that strongly correlate with your target. It could be gold, you can have arsenic, you can have silver, based on the kind of vicinity that you're in. So you should know. You can also have, let's say, antimony and the rest. They might not be strong correlative indicators of whatever deposit they are looking at. But there are some group of trace elements or pathfinder elements that you look at when you are running your analysis or geochemistry analysis in determining the kind of deposit that you are looking for. And those are some of the elements or pathfinders that you should be looking at. Sometimes the software makes it easy for you. When you, let's say you get your results back from the lab, an ICP-MS analysis that's been done on, let's say, 100 of your samples, and then you get the results back. When you run the data through your software can actually pick the major ones that you're looking at and then the minor ones that you're looking at. And then most of the time you see your major ones strongly correlating with whatever deposit that you're looking at. I hope that answers your question.
Okay, thank you very much. This is from Jeff Tabonzi. Thank you for the presentation. I want to know some of the critical roles machine learning can play in terms of finding deposits. I think that's pretty much what Engineer Henry hammered on. Or if Mr. Kwesi still has something to add, we will take it and move to the next question.
Okay, so let me just use an example. I went for a workshop at Anglo Gold, and then they explained to me how they are able to make sure that everybody locks the same thing. Sometimes, geology can be also perceptive, and somebody can see a very fine grain rock like phyllite, and somebody can call it shale, somebody can call it phyllite, based on probably where you've worked before, your familiarity with that kind of rock. Now, when you have machine learning, you have AI, okay, you have a database of some of the things that the software should look out when it's doing its interpretation. So I did not get to have a display or have a feel of how the software works. But what my understanding is, when you are doing your login, there are some drop boxes that appear that you choose. And then that should actually lead you to determine that I've logged sandstone, and it should also remain sandstone based on what, let's say, your duration, your color, and then whatever other properties that you look at. And that's where machine learning and AI comes into this. At the end of the day, when you do load your data into the database geologist also to make sure that he has cleaned the system, and then the data that you are bringing is a correct representation of what is in the ground or what you have logged. And that's where sometimes these softwares come in. They can already, some of these software can even help you determine whether you've logged a wrong from to, or a wrong an interval that does not look right. Sometimes the software can pick some of these things up. So that's how they have integrated into their system to make sure that the geological database is as accurate as it can be.
Thank you very much. This is from Moses Aka. Thank you so much for the wonderful presentation. Please, my question is, in your experience, how do you differentiate between Pathfinder elements that originate from the ore bodies and those that come from unrelated background sources?
So, like I said, geochemistry you cannot use that as a standalone how do you call it, method in exploration. Let me just use an arsenic anomaly as an example. So let's say you go on the field and then you start picking your samples and you start running analysis, and you see arsenic. You see a lot of arsenic in your samples. So that might give you an indication that you are closer to a gold deposit. Now, if you have faults in the ground, probably faults that you cannot see, you have fractures and cracks in the ground, this arsenic can also seep through it through these hydrothermal fluids, can seep through cracks and faults, and it can also give you a false sense that there might be gold there somewhere. But also, you should also look at it as if the place has been structurally disturbed. So you should also be expecting that you might have some geological fluids that might have brought some of these anomalies close to the surface through some of these structures.
Okay, thank you very much, Mr. Kwesi. This is from Ferguson. When you detect a strong Pathfinder anomaly, but no corresponding economic metal anomaly, how do you make the decision whether to drill or to continue surface work?
Oh, okay. So, like I said, you don't use geochemistry as a standalone method in your exploration. You should actually correlate. Let's say you're looking for gold. You should actually have strong correlation with your gold as say. Because if you've done your interpretation and realize that your gold is concentrated somewhere other than the concentration that you are seeing in your Pathfinder anomaly, which is also elsewhere, your best bet is to go after the gold anomaly, and then you can target your geochemistry anomaly after you are done sterilizing the area with the gold anomaly, because now your primary goal is to look for the gold, not just trace the geochem anomaly alone. So if it were me, based on my experience, I'll actually make sure there's a correlation. Now, if there's no correlation, then my best bet is to go after the gold, do my sampling, my mapping, my trenching, whatever that it is, and actually drill there before I can move my concentration elsewhere. That's what we would call targeting and then ranking. Target ranking. You rank your targets based on so many factors that you actually put in place to make sure that you attack the target with the most reasons that tell you that you find something there before you move to lesser targets.
Okay, thank you very much. This is from Kwame Frempong. Please, Mr. Kwesi was quite optimistic about the future of AI in exploration. Machine learning models are quite narrow in their functioning, in that machine learning trained in specific areas or regions work better in areas with similar character as those regions where the machine learning model is trained. So I want to ask, how flexible is the industry when it comes to providing geochemistry data to students or researchers?
So the question is about acquisition of geochemistry data for students or those who are doing research, right?
Yeah.
Okay, so just like any other way that you acquire data from a mine or a company for your research, it's just the same. So if the company or the mine has run geochemical tests on a particular area, yes, of course, you can acquire the data, but you do know there's a procedure and process to follow in the acquisition of that data. I don't know for other companies, but I know for here, you do have to write a letter to the geology manager, and then you can follow the due. There's a process in acquisition of that data. So,
Maybe I can add to that. Sometimes some of you don't go through the right procedures. One of the general managers was telling me that all of a sudden he got a cold email on a student requesting for data and so on. Typically, you should go through your department, whoever your supervisor is, and let that department write on your behalf, explaining the purpose of the research, and that makes things a bit easier. And you should know the channels to go through. A lot of the companies, you have to go to the human resources department, or if you have the direct link to the geology department or mining department or whatever, you go through that. But you just don't send cold email to a general manager that you want data on A, B, and C.
Okay, thank you very much, Engineer Henry. The last question here is, what are the notable or distinct features of weathering and transported distortions? What are the notable or distinct features of weathering and transported distortions? And how would a geologist go about it? Whether there will be a target or he has been chasing distorted anomalies with no real target.
So like looking at the trace elements or pathfinder elements that you might consider for a particular geological setting, there are some certain trace element and path element that you will definitely be looking out for when you're on the field. Now, so if you have, let me just say, a porphyry copper system and then an orogenic gold system, you have these two deposits in the same area. Sometimes if that happens, you can find gold and discover copper too at the same time. Okay, depending on the kind of mineralizing system that deposited some of these deposits, you can have, let me just use the word contamination of your trace element and pathfinder elements. You have them mixed up, and having them mixed up might actually just throw you off, because then it makes the interpretation difficult. Because you are finding this and you are finding this, and it is pointing you, let's just say, opposite direction, or it's pointing you at the same direction. Okay. But now your target is you are looking for gold, but you are having concentration of elements that suggest that you should actually find copper. I hope you guys understand me.
Yes, please.
Yeah. So sometimes when it happens this way, it might be possible that you cannot use this method. You might actually have to rely on other methods. That's why there's not just one method or one process when you're conducting exploration in a particular place. You should make sure that you follow due process and exhaust all your options before you call it a wrap.
Okay, last question from Clementia. Thank you so much. Mr. Parkwesi, since the off-forming fluids are pervasive and superficial processes, if not all, but most of the obvious soil geochemistry signatures have been discovered and mined, would you say the next generation of gold deposits will be associated with little or no soil geochemistry signature, that is, geochemically buried or blind?
Okay, so per my understanding, one thing that I know for sure that she might say all the deposits have been discovered, but I don't agree with that. There are still a lot to be discovered. Let me take Ghana as an example. Yeah, if you look at the geological map of Ghana, you see that where the Volta River is, there's a Volta basin there that shows a very thick overburden of sedimentary deposits, which covers our gold belts. They all strike in that direction and they go under the, how do you call it, the Volta basin. That should tell you that it doesn't end at the contacts between the basin and then whatever formation that you're looking at. It still continues. It runs under. And like I said earlier, if you have a very thick overburden, maybe geochemistry might not be that method for you. There are other ways of going about it if you do believe that there's something out there.
Okay.
So like sorry to cut you short. So like as she's saying that maybe yes, the minerals or the minerals of interest that probably outcrop to the surface, maybe most of them have been discovered, but there's still more out there to be discovered, far more out, a lot out there to be discovered.
Okay, this is from Mr. Edward. He's asking, please, has there ever been a situation where geochemical results for soil sample deceived the exploration team? Also, is it very reliable to make decisive decision with geochemical data from sampled soil for an area of prospecting?
So I wouldn't say deceive. Deceive is probably a strong word. So like I said, when you conduct exploration, it is not set in stone that you are supposed to discover something. You might go about and follow every process or every apply every technology that you have out there in your exploration program to discover something. But it's not always that you find something. But one thing that you should know, like I said, and that is why exploration is not conducted by one person alone. You do have a team, your peers. You review your work, you troubleshoot your work, you brainstorm. Okay, so there's no way you can have the results deceiving you. You do have the results, and you're also supposed to back it up with what is on the ground. So what do? You do ground truthing. You have your results, you go to the ground and make sure that what you are seeing with your interpretation, you are seeing it on the ground. And then what you further back it up with what? Drilling, soil sampling, trenching, field mapping. If it's there, it's there. If it's not there, it's not there. But it might be, yes, we are all human beings. There are some errors that can be made. As human as we are, we can make errors based on our interpretation of what we think might be there. And also sometimes too, as time goes by, new technologies come that even allow you to come back and further explore more, and that can also lead to a discovery. Maybe currently you are limited by the kind of the technology that's at your disposal, but does not mean that you probably been deceived. It's me, I see it as maybe you have been limited or incapacitated to continue because we have certain limitations that have come in based on technology.
Okay, thank you very much. This is to Engineer Henry. Please, considering the limited exploration works in Ghana, what preparations can put with the young professionals at the forefront to set us for employment?
That's a very interesting question. Maybe you should ask, the chairman can help us with that, because that's what you are doing at the moment, trying to get your education, organizing these workshops to enhance your knowledge and so on. The challenge in Ghana is we are not getting many companies doing exploration here. And I keep on telling the Ghana government that between 5 to 10 years, Ivory Coast will overtake Ghana in gold production, because a number of companies are going to Ivory Coast, but the geological potential in Ghana is much, much better than the Ivory Coast. And so if we don't address these structural challenges, especially the key one for investors is illegal miners intruding into legal operations. And when I travel across Ghana, from Newmont to Asante Gold to everywhere I go, there are instances of intruders into legal concessions. And this has become a huge risk for investors trying to come to Ghana. When we were signing this MOU with this Australian company, that was their biggest concern, that they do all this work, spend millions of dollars, and it's all encroached by illegal miners. As I speak with you now, I have a good friend in the Kwesi area, a very good mining engineer. He's gone through the ranks and decided to buy a concession that has been seeded out by AngloGold Ashanti of Kwesi. Now he spent a lot of money proving up the resource. He's now getting funding to start developing the mine. And all of a sudden, Galamsey's have taken over. He's reported it to politicians, the security services, and so on. They've actually built camps there, mining in his concession. So unless these structural challenges are addressed, then it's going to become very, very difficult. The problem with geology is you've got UMaT, KNUST, UDS, University of Ghana, and others all offering geology courses. So hundreds of you are coming out in the field with few jobs. When you talk to the general managers, maybe 10, 5, and so on. Each mine can do just as much as they can. And so you're going to have hundreds of you without jobs. When I say jobs, geology-related jobs and so on. So that's why I always call for diversification. You don't sit and say, I can't find work in geology, so I won't do anything. That's why I like this geologist who is now in the DRC. She had a vision. I've got 2 years. I'm not doing anything. She went to do an MBA, skilled up her skills, set up a business, a small business. And all of a sudden, she's been thrown into the deep end in the DRC. The good news for Ghanaian geologists is there isn't much expertise across Africa, especially the French-speaking countries, Burkina Faso, Ivory Coast, Senegal, and so on. So even in our projects in Burkina Faso and so on, we send Ghanaians. I'm the chairman of a company where national service personnel have been taken overseas on geotechnical work. Somebody was asking me whether even foreign national service can go overseas and so on. But the CEO tells me once he's registered, his company is here and jobs are running out of Ghana, he can send them overseas. The whole intent is to bring them back with some level of expertise and so on. So it's a challenging one. You can do whatever you can, but I keep on advising that when you get opportunity, use it. I have a mentee in Obuasi, and what I told him is, you cannot go and do the status quo of 8 o'clock to 5 p.m. because I speak a lot to your managing director. I have lunches with him when I'm in Ghana, and I know that he doesn't have the budget to take all of you for graduate training. And so what he needs to do is to position himself to become employee of choice, pick a project that will add value so that when the time comes, they'll remember you. He did exactly that. And when I checked after the graduate national service assessment test, interviews and so on, I checked and I called one of the managers. His response was, even if he didn't do well at the interview, we cannot get rid of him because his project is actually going to add value and they want to see him around. So even if he did very, very bad at the interview, there's no way that the mine will throw him out. So when you get these opportunities, the small opportunity that you get, you need to grab it. And some of you are so negative. And this, somebody has been given a national service with one of my companies, Pamico. What does he do? He calls the CEO, the executive director. I've been posted to your company in Pamico. Can you tell me what Pamico does? Not even to the HR. He's calling the executive director to find out what Pamico does. He's not doing any research. So what does he do? You know, Peter, the guy who chaired our function, he's a no-nonsense man. He just called the HR department to get rid of the guy. He doesn't want him. And so when you get opportunities, you need to take it and ensure that you are adding value. It doesn't mean that as soon as you go, you are trying to find something and say, I'm going to add value. Once you find a gap, discuss it with your peers, with your supervisor. This is what I found. Maybe there's a reason. Maybe somebody has looked at it and it didn't work. And then you can capture that opportunity and so on. So it's a very tough environment. The good news is a number of initiatives are going on in Ghana that a lot of you are not aware. A lot of you concentrate on gold, but there's a huge iron ore potential. There's a company called Ghana Integrated Iron and Steel Development Corporation that is going into joint ventures with explorers, exploring for iron ore in the OT region and other areas. And some of you don't know, you only apply to the gold fields, the Newmonts, and so on and so forth. These are opportunities. There's JADED, Ghana Integrated Aluminum Development Corporation, looking at development of bauxite and so on. And so you have to look outside of the box. Somebody sent me a message yesterday. Can I direct him to companies? He's a lazy guy. Instead of sitting down and doing research and finding out the companies around, doing exploration and so on, you are telling me I should give you companies that are in Ghana and so on. So you need to take bold initiatives to make yourself employable. Otherwise, it's really going to be a challenge. Thank you.
Thank you very much. We are running out of time, but we'll read the last two questions. This one is from Abdul Mumin. Please, I have a question related to structural geology. I would like to know the difference between slope angle and dip angle. Mr. Kwesi. Hello.
Let me help Mr. Abdul. This question doesn't need to be answered. Go and do some research and then come and report back to me. This is something so simple that you can find it and so on. So I'm going to give you a challenge. Go and do some research and report back to me in 2 days' time.
Okay. We are taking the last question from Mohammed Abdul Jalil. Thank you, Mr. Kwesi. As an exploration geologist, what will be the ideal geochemical analysis to run on soil samples in search of gold? Should it be just the gold analysis, or you can add the pathfinder elements in the initial stage? Looking at how the huge number of samples will be in large-scale exploration. I joined the meeting late, and I don't know if you've spoken about it already.
Yeah, can you hear me?
Yes, please.
Okay, so when you receive your samples from the assay lab, so they will run their own test on it, call it a fire assay, and then get you the gold concentrations in the samples. Now, as you are picking your soil samples, you can just conduct XRF data collection whilst you are picking the soil samples. So if you are in the office, you with XRF data collection, if you use the XRF gun, you immediately have the data, you can run your analysis on them or your interpretation on them whilst you are waiting for the results to come back from the lab. And then when your results come back from the lab too, you can also make sure that the XRF results data that you collected, it's accurate by sending the pulp of the samples that returned back from the lab to another lab to do ICP-MS on it. So you can run these two tests concurrently. XRF fire assay for your good assay results, and then you can run ICP-MS2 on the pulps that come back from the lab, and then compare the XRF and the ICP-MS. Because the ICP-MS is, they are all different methods of collecting geochemistry data, but some of them are much more accurate than the other. You get to, so you can just run all these things concurrently or at the same time and do your interpretation and then compare.
Okay, thank you very much. That's a wrap for the question and answer session. We'll take the chairperson closing remarks. It will be from Dr. Kofi Adomako Ansah.
Yes, thank you very much, Mr. Moderator. And in fact, for all of you listening on this platform, in this workshop, I think that you have been fed very well with everything that pertains not only to geochemical fingerprinting in finding the ore deposits, but also things related to you as students and how you get into the industry as a whole. So I must say a very big thank you to our guest speaker, Mr. Kwesi Eduku, for that enlightenment that he has shown and thrown onto us. And then also to the founder, Mr. Harry Antwi, for such elaborate exposition on the industry academia student relationship as well. As an economic geologist, well, you say economic geologist because sometimes when people hear economic geologist, they think that we are doing economics. But the main thing is actually that the economics of the metals that are of interest, that is what we are focusing on. And in simple terms, anything that is worth economical, any S material that is worth economical is what we are interested in, or I'm interested in. So in my own profession, I combine geochemistry to my geology in order to, explore and then determine the genetic processes and the concentrations and resource modeling of these metals. And if we have heard all that has been going on, you realize that, number one, you need to combine various facets of your work in order to establish the ore deposit. So that if you have, in this class, in this workshop, we specifically looked at geochemistry, but then you realize that it's not going to be only geochemistry that you will need to essentially establish the ore deposit. You will need to combine other tools or other survey skills to be able, to establish whether you have an ore or you do not have an ore. And those important things, we were made to also realize that there are various, approaches that you can, carry out in terms of the chemical fingerprinting. Things like elemental ratios, things like isotopes, things like even using the chemistry of the minerals. All of these can help with you targeting the ore. And then more importantly, trying to combine the fact that you are students and you'll be looking for employment, when you are done with your studies. I must say that I'm appreciative of Mr. Dr. Antwi in setting up AusIMM Student Chapter and making it run as it is running, because you are being given opportunity and information as to what is going out there in industry, not only in the classroom, but also the opportunity to experience what is also going out there in the industry. And therefore, by the time you should go through this process, by the time you get to your final year, you will have had, much information that should prepare you, to graduate as a full-fledged graduate for the industry. The other thing that has been noted here is that there are so many of you, and therefore you must make yourself count in that particular training that you are going through. For example, if you are being trained as a mining engineer, if you are being trained as a geologist, if you are being trained as a geochemist, whichever area that you are being trained for, you have to understand that you are not the only one going out there. There are so many of you. So you must make yourself relevant. Make yourself relevant, and that will take you to places. I remember for some of us, unlike your time where you had all of this information, we didn't have as much information like this when we were in school. But so when we had to graduate, I, for one, I had to write letters to the companies. I didn't know anybody. I didn't have any information about anyone. And that is how, in one way or the other, I received a response from Damango Fields. All right. I couldn't go there because at the time the results came, I was doing my national service in a town where I couldn't have access to phones, to the internet. So that is how I missed out on my job opportunity. I think I got to know about it about 3 months after they had been calling out for me. Because of where I was, I couldn't get that information. But you have enough of information now to be able to make very good decisions about your future. In actual fact, it doesn't really matter whether there are many of you or there are few of you. Once you have inculcated the habit of entrepreneurial skills, together these can help, make you the intelligent and smart people that we believe we are training you to be. So on this note, I am very, very excited that as we are leaving here, we are going to be leaving with this special understanding that what others have done, you can also do. What Mr. Eduku has been able to share with us, they are things that you can also learn and then also follow. What Dr. Antwi has also shared with us are things that are nuggets that you can also do and then become the professional that you need to be. So on this note, I say thank you very much once again, and I hope to see you all in coming out as great geologists, as great miners, and as great entrepreneurs even in this time. Thank you very much for your time.
Thank you very much, Mr. Chairperson. We will take the vote of thanks from Mr. Techi Stephen. He's the Deputy Head of the Geology Department.
This has been an insightful section. I've gathered enough information, and I believe you have too. As we bring this insightful workshop to a close, briefly, I would like to express our sincere gratitude to Dr. Kofi Adomako Ansah for chairing this program. To our speaker, Mr. Kwesi Eduku, we say thank you very much. And to our founder, Engineer Henry Antwi, we appreciate all your efforts in making everything a success. Lastly, we recognize the efforts of the Geology Department of the AusIMM Student Chapter for organizing today's event. Your hard work has made this experience possible. We look forward to seeing you at future events, and we believe that anytime we gather here, you are going to join us. And I'll urge each and everybody to put down whatever they studied in the main group so that each and everybody can also benefit. Thank you, and
thank you very much. So all too soon, we've come to the end of this workshop. This has been nothing short of insightful and educative, as we promised at the beginning, from learning about geochemical fingerprinting to navigating work life and how to position ourselves as employable people. Thank you to the organizers of the program, to our founder, the chairperson and speaker, the Geology department, and everyone for joining. Suede Zahir is my name, and it's been an honor moderating this program. Thank you, and catch you next time.